This week we are studying the muscular system. So what are some of the purposes of the muscular system? It's pretty easy, a little simpler than the other systems we've done. Purposes of the muscular system? Yeah. Like I said, pretty easy. So movement of all types. And as we mentioned, this type of movement, it's going to be everything. Everything from your heart beating to breathing to the more common moving your muscles and bones and walking around. So, movement of all types. Is there anything else the muscular system is doing for us? Anything else? Yeah. Yeah, it's assisting with other things. So what we're going to find, the more systems we study, all of the systems actually overlap with each other. Okay, so of course the muscular system is going to do things like help pump the blood and help digest the food, but we're not going to count that because that's muscles that are in the other systems. The only other really major thing the muscular system is doing is it actually is providing protection. Remember, the skeletal system provides protection. The skeletal system, very obviously, the skull, the rib cage, all that is protecting things. But in places where you don't have bone, right? You've got muscles around your abdomen, you've got muscles on your legs. Most of your big arteries and veins are deep underneath the muscles. And so there is an element of protection of organs as well. So next, let's look at the three types of muscles. Let's look at voluntary and involuntary muscle. So let's take a quick look. And it gets a little confusing because, for instance, the textbook will say something like, what are the three types of muscle, or what are the types of muscle, but does it mean skeletal, smooth, and cardiac, or does it mean voluntary and involuntary? So let's do both of these. All types of muscles can be defined both ways. So let's start with this because this is on top. Voluntary muscle, involuntary muscle. Which is which? What do these mean? Yeah. Okay, so voluntary, you control by thinking about it, right? You volunteer the muscle. You say, okay, move my arm. And this includes things like some people think, well, walking is involuntary because I don't have to think about it. Yeah, but you had to learn how to do it when you were little. So if you had to learn how to do it, if you had to practice how to do it, that's voluntary. You control by thinking about it. So for example, walking, almost all skeletal muscle. Okay? So then what's involuntary going to mean? What's that? Yeah, it's not so much that you can't control it, because we do have some measure of control, but the involuntary is automatic. Yes. So like blinking is automatic. What else? What other movement do we do that's automatic? Okay. Blinking, breathing, your heart beating, and what else? What about smooth muscle? Smooth muscle? Voluntary or involuntary? Okay. So I think all of the smooth muscle is involuntary. So digesting, all of the smooth muscle. Okay, so now, even though we kind of did this already, let's do a little bit more detail on each one of these here. Skeletal, cardiac, and smooth, just to be specific. All right, so skeletal muscle, as we mentioned, pretty obvious, is found attached to bones. Mostly. Tim and Moby mentioned yesterday, there's also things like the muscles in your face that allow you to smile and blink and make funny faces. Those ones are attached more just to the skin. There are some examples of skeletal muscle, but for the most part, if you think of skeletal muscle attached to your bone, that's where they are. Now, skeletal muscle, and I already kind of said this, is this usually voluntary or involuntary? Voluntary. Yes, it's almost always voluntary. Question? Yeah, the textbooks that involuntary are muscles that you can't control. It did say that. Okay, so you cannot control them. The reason I said, so he said the textbook says that involuntary muscles you cannot control. The reason I said you kind of can is because by relaxing or thinking about it, you can calm down your heart rate. You can, if you're really stressed out, your digestive system doesn't work as well. So for the most part, they're not under conscious control, but you can control it to some extent. Right. Okay. So that's actually where I was going to go next. There are a couple examples of skeletal muscle that are both voluntary and involuntary. And one of them, so it's mostly voluntary, and then there's some that are both voluntary and involuntary, and that would be blinking and breathing. Guys, you need to be writing this down. So, blinking, there's muscles that surround your eyes. So that I'll show you back on the muscle guy back there. But there's these circular muscles surrounding your eyes. You can blink on purpose, obviously, but you also blink automatically without thinking about it. Similarly, for breathing, as you know, there's this big flat muscle here at the base of your rib cage called the diaphragm, and that muscle, most of the time, works all by itself without you thinking about it. There's also muscles here in between your ribs called the intercostal muscles. That's the in between the ribs muscles. And those also contract. You know when you have ribs, barbecued ribs, that's what you're eating is those muscles. And so those ones contract automatically when you're constantly breathing, when you're sleeping all the time. But you can hold your breath. You can take a deep breath. So they do have both control on that. Can you think of any other skeletal muscles that are involuntary? I think that's the major examples. And again, there are a lot of things with skeletal muscle, like walking, things like that, that seem involuntary, but you did have to learn to do them initially. And so it is actually voluntary control. All right, questions about skeletal muscle. Next is smooth muscle. Smooth muscle is found in the organs, and that might seem confusing because you're like, what organs need muscles? Well, the biggest, most obvious example is throughout the digestive system. Once you swallow your food, chewing and swallowing is obviously voluntary. Once you swallow it, there's muscles in your esophagus, there's muscles in your stomach that mix it, there's muscles in your intestine that squeeze things out, there's muscles in your small intestine and large intestine that keep everything moving all the way down, all the way to the end where you need a voluntary muscle so things don't move out until you want them to. The other place you will find smooth muscle is also in the blood vessels. Your blood vessels, blood vessels dilate or contract, right? Depending on if you're hot or cold. So you flush and get red if you're warm, and your body needs to dump off heat. It regulates your blood pressure by having them dilated or contracted. That's smooth muscle. Those are the main places. And then any other thing, next week when we talk about the digestive system, there's a lot of places along the way where stuff gets squirted into the digestive system, like the saliva glands, or bile from the liver, or insulin from the pancreas. All of that are little muscles that are adding stuff to your digestive system. And that's all smooth muscle. You can't control that. Yes? Why is it called? Oh, good question. Why is it called smooth muscle? The textbook has a really good picture, and I will cut and paste some pictures of it. I don't think I have it here. I need to cut and paste them from the textbook. But the reason it's called smooth muscle is when you look at it under a microscope, it actually looks different. And the skeletal muscle is what's called striated or striped. So when you look at it under the microscope, it actually has this kind of striped look to it. And the cells are all kind of long like this, side by side, muscle fibers. But there's also kind of this striping to it. And I'll have you get out the textbooks again and you can look in a minute. Or I'll look it up for you. And then the smooth muscle, you don't see that. And then the cardiac muscle actually looks like a cross between skeletal muscle and smooth muscle, which is interesting because functionally it kind of is. Cardiac muscle we find where? In the heart, only in the heart. It's a very specialized muscle. It beats every second of every day from before you're born. And it doesn't get tired. It beats faster, it beats slower, mostly involuntary, right? Again, you can kind of calm yourself down and slow it down, but other than that, your heart rate, your heart muscle beats all the time. And so this is obviously involuntary. Okay, and then I think, does everybody have that? I wanted to show you, I think we just did all of this, right? So this is stuff you'll need to know for the quiz. And as you're writing your conclusion, cardiac muscle, smooth muscle, skeletal muscle. Where is it found? Is it voluntary or involuntary? And what's it doing? So we just did that. That's just another version of the same thing. And this is a worksheet that I was going to have you do today, but the copy machine broke yesterday, so we don't have it. But this is something that you can add to your skeletal muscle and smooth muscle. This is another really interesting thing. Skeletal muscle, right, attached to the skeleton, yes, it's voluntary. Sometimes it's involuntary. It reacts very quickly, right? You need to get up and go, you get up and go. You stop, you stop. Reacts quickly, but it also tires quickly. Get up and sprint, okay, need to rest. Need more oxygen. So skeletal muscle reacts quickly, tires quickly. Smooth muscle in your organs, is it voluntary? No. Is it involuntary? Yes. Does it react quickly? No. But does it get tired quickly? No. So the smooth muscle, part of what it does is that it never gets tired, but it just moves at its own pace. You know, so digest that food right now. It just does it as it needs to. And then finally, cardiac muscle is very interesting because, so it's involuntary. Does it react quickly? Yes. If you jump up and start running, your heart immediately starts beating faster. Does it tire quickly? No. And so it's a very interesting combination of those. So that's just something else you might want to look at when you do that. And next we're going to talk about skeletal muscles working in pairs. Question?
Is the smooth muscle what cramps?
Skeletal muscle that cramps. Skeletal muscle cramps because usually you're not getting enough oxygen to it. And so your muscle is saying, help, I can't contract anymore. Yes? It does kind of. So the cardiac muscle does kind of have the best of both. And some people will say, well, why don't we just have cardiac muscle in our whole body? Yeah, I'm guessing it either takes a lot more energy, it is involuntary, you can't really consciously control it. But yeah, yes. Ooh, the longest muscle. I'm not sure. I would guess there's one called the sartorius muscle, and it goes from all the way up here at the top of your leg, on the outside top of your leg, to the inside of your knee. And it's a long, thin muscle that goes there so that you can turn your leg. I would guess that's a pretty long one because the femur is the longest bone, and it kind of goes along that. Okay? All right, let's do a quick thing about muscles working in pairs, and then we'll do a little activity to practice this stuff. Okay, you read, and we're of course talking about skeletal muscles. So you read yesterday, why do skeletal muscles work in pairs? Ladies, can you get rid of that and write about muscles working in pairs? Thank you. Muscles working in pairs. Why do they have to work in pairs? Yes. Not exactly, kind of. Anybody else? Yes.
One muscle is left to work alone. They can't move the arm.
Yes, right? But why exactly is that? Okay. So muscles can only contract. They can only really move one direction. So if you need to move the other direction, you need another muscle. And so everybody can do this right now, right? So if you put your arm, if you got your bicep and your tricep, right? And I think I have a picture of them here. Aha. That's actually a chicken wing. Here's, oh, let's take this. We're going to take this and move it back over here. Okay. So let's take the arm muscle here. Now we can look at a couple different muscles here, and I want you guys to try this. So this, of course, is the bicep. And this is the tricep. So the bicep is connected right here to your forearm bone, to your radius, and up here to the top of the humerus or to the shoulder. It's actually called the bicep because there's biceps, two heads, two connections. Okay? So when you contract this muscle, it moves your arm up. And so what I want you to do, put your arm loosely on your bicep and move your arm up. Okay, so you can feel that bicep getting bigger. It gets fatter on the middle as all these fibers contract to move your arm up. The tricep actually moves it down because the tricep is attached here. Okay, hey guys, here's one other example. This one's a little better at how you move, how you need the pairs. So in your forearm, on the top of your arm, these are called the, here, let's do it this way. Turn your hand up like this, right? So your fingers are up like this, okay? And so these ones on your forearm are called your flexors. And these ones on the back side of your arm are your extensors.
Wait, Mr. Donovan, the fingers have no muscles.
They do.
And only tendons.
Okay. What happens is the muscles are above. So, for instance, your bicep and tricep are up here, whoops, but they're moving this part of your arm. These muscles in your forearm are actually moving your hand. So if you hold your hand up this way, flex, extend, and again, if you put your arm loosely around your forearm when you do that, you can actually see them, or to the side, you can see them squeeze and extend. So your hand, your fingers are moving because of the muscles in your arm. There are also a few muscles in your hand for that too. But your fingers moving, as you know, as you might guess, there's very long tendons. You can usually see them in the back of your hand. Those tendons are attached to these muscles. So if you wiggle your fingers, you can see these. Also, kind of creepy, if you relax your hand this way and then push on these tendons, it will move your fingers. So tendon, remember, tendons connect muscle to bone. Tendons connect muscle to bone or muscle to muscle. Okay, I believe that is what we need. All of this information will be very useful for the quiz this week and also as you write your lab conclusion. All right, last of all, tomorrow when we look at the chicken wing, what you're looking at in the chicken wing, it turns out you're looking at the arm. The chicken's arm is obviously folded up, but it's the same bones. Here's the human arm, humerus, radius, ulna, hand, and the reason they have it kind of at this funny angle is because it's the same thing with the chicken. We will look at this again before we start the lab, but this right here, when you eat chicken wings, this is the yummier, fatter, not fatter, but yummier, meatier part, right? And then this part is the part of the wing that has the two bones and not very much meat. So the part of the wing that has all the meat is the bicep tricep. The part that has less meat is the forearm, the radius ulna. And then the fingers are kind of fused into this crazy wing and thumb.